So these are the ways how we can collect data that we can then use for more in-depth analysis. And for quantitative analyses, quantitative methodologies, we always need statistical measurements. Statistical testing is really what makes the key thing here, because you'll always find some sort of a relationship, some sort of correlation in data, but you really want to know if it's really a true effect or if it's really just an artifact. Statistics for some has become something of a bad word. It's hard, it's math, it's unnecessary, but it's really the key driver of the reliability, of the validity, and the strength of a certain piece of research. Key questions are always what kind of tests to use and which kind of test would be applied. A key difference that needs to be made for the selection of tests: we cannot cover whole field of statistics in a 45-minute session, not even now in the last 10-15 minutes. But this is something that you as researchers will really always have to work on. There's no way around a statistics course. It has to be done. But to make some key distinctions here, there's different kinds of data. First kind of data is categorical data. The other kind of data is continuous data. Categorical data means you can nicely group it into categories. It's clear boxes, of which there are several. Continuous data means that there can be a very wide range of diseases. It's a continuous spectrum between 1 and 5. There's 1.1 and 1.2 and 1.3, but also 1.11 and 1.111 and so on. The type of statistical tests you can run differs by the kind of data that you have. Categorical data, for example, would only be A1, A2, A3, A4, A5, or a yes, no, maybe, or a high, medium, low. And it's really can't be anything else from that. It's very categorical, it's clear cut, and it cannot blend into the other category. So for the script for categorical data, there's quite a few of descriptive statistics, typically comes down to frequency tables, and very commonly used tests here is the chi-square test. For continuous data on the descriptive side, you'd rather use something different. You'd use something like scatter plots, because they can show this continuous nature of the data that's underlying it. The typical tests used here are Spearman's or Pearson's R-test. And the test is always there to determine correlation, to examine whether there is a relationship between variables or if there is not. As I said, the test selection really depends on the data that you have generated, that you've available from the data that you've gathered. For categorical data, usually the standard is chi-square testing. If it is ordinal data, so that means ranked data one after another, Spearman's row is typically used. For interval or for ratio data, Pearson's R is the most commonly used test. There's also regression analysis methods, so linear or bivariate. Also logistic regression can be used. This very much depends on the data, very much depends also on your objectives for the study. So these can work very well. This can also lead to something you can describe as overfitting, where you're really looking for a association that might not be there. There's additional statistical testing to really come up with a reliable measure of the validity and of the probability that is what you're looking at is really a true correlation.